Hi, welcome to this walkthrough of the carboxylic acid and esters question pack. So we'll start looking through these reactions and try and get to grips with it for you. So the first question, a student analysed a mixture of compounds found in red wine using gas chromatography followed by mass spec. Two of the compounds found to be present are shown below. We've got compound A and B. In red wine, compound A slowly forms an ester. The formation of the ester can be done in the lab, as shown in the flowchart below. Separate portions of compound A are used in the formation of the ester. Okay, so look for these important instructions here that helps you work out the synthesis. Complete the boxes in the flowchart below. So look, whenever you're dealing with anything to do with any synthesis, if it's looking at a specific functional group, whatever, the idea is focusing on the changes that are taking place. The molecule's main structure won't change. All that will change are bits around the functional group. So you've got to link in the reactions you've learned of all the different functional groups and look at what's happening to the molecules. How are they changing? So we take the first step here, the first half of this reaction. We can see here we've got this benzene compound here with an OH group directly attached, so we can classify this as a phenol. And we've got a CHO here becoming a COOH. So we can see here I've got an aldehyde attached to my benzene ring, and that's becoming a carboxylic acid. So you've got to think, how does that happen? What reaction takes place to convert an aldehyde to a carboxylic acid? And this is oxidation. So I can oxidize an aldehyde into a carboxylic acid. And then how do I do that? The reagents necessary for oxidation of an aldehyde to a carboxylic acid, I need acidified dichromate ions. Okay, it's just asking for the reagent, so you could put acidified potassium dichromate in words, or H plus and K2Cr2O7, or H2SO4 and K2Cr2O7. Any combination of acid, hydrogen ions, and dichromate ions will cause the oxidation of aldehyde to a carboxylic acid. I would also see an orange to green colour change in this process as well, as the chromium ions then form, 3+ ions form as a result of the reduction of the dichromate ions. Okay. So what's going to happen then in the second part? Well, I've got my aldehyde compound, separate part of compound A, now using NaBH4. Now this is a reducing agent. So NaBH4 can reduce an aldehyde to an alcohol, and aldehydes reduce back to primary alcohols. Think of the same process. Primary alcohols oxidize to aldehydes, which can oxidize further to carboxylic acids. Secondary alcohols will oxidize to ketones. So because I've got an aldehyde here, this will reduce the reverse process, the aldehyde, back to a primary alcohol. So what I get here, my benzene compound, well, the phenol compound, would have a second carbon there. Remember, we've got a carbon, so we can't lose that one. So this is a primary alcohol forming here, so I'd form that compound there. Okay. Now, what's happening? I'm trying to form an ester. All right, think of the many ways we can form esters. Esters are reactions between carboxylic acid and alcohols, or acid anhydrides and alcohols, or acyl chlorides and alcohols. In this instance, I'm trying to form an ester. I've got, from the first half of this reaction, I've got a carboxyl group here, and I've got an alcohol group on there. So I could form an ester between the COOH here, this benzoic portion of my molecule, and the alcohol there. I could form an ester between the benzoic acid group here and the OH group there. Okay, so there's two possible esters that could form here. So let's draw it from this carbon, from this one here. It doesn't matter which one you choose, both answers would be right. Okay, so I could form the ester thusly. Okay, so this C here is going to be this of the carbon off the COOH here. So now I'm going to have my benzene compound, benzene ring. So you've got to think about your orientation, because I've sort of flicked it around a bit. Think about where the OH is bonded to. The OH is bonded onto the third carbon. So if this is my COOH here, that's carbon 1, 2, 3, my OH would be there. So that would be a perfectly suitable ester to go for off this compound. Part 2, give the mechanism to show the formation of compound C in reaction 1. Okay, so we're looking here, so I've got my reduction of my aldehyde group to the primary alcohol. So this is the mechanism to show that process. Okay, so give curly arrows to show the formation. So it's reduction. So let's start off with drawing out my compound. Now, whenever you do a mechanism, you need to show where all the curly arrows are going to be. So I would recommend you draw this out in displayed formula, so in essence like I've done here. Okay, so I've got my aldehyde group, C double bond OH. Okay, now think about it, the NABH4 is a reducing agent, and the ion then, the nucleophile that's taking place in this reaction, it's a nucleophilic addition reaction. The nucleophile is a hydride ion, a negatively charged hydrogen particle, a hydride ion. So this is my nucleophile, it's negatively charged, it's going to be attracted to a place on this molecule which has a positive charge, an area where there is electron deficiency. Now this C double bond O is polar, so I can put dipoles onto the C double bond O, delta positive on the carbon, delta negative on the oxygen, which means my nucleophile is going to be attracted to and attack the carbon atom in the C double bond O. So I need a curly arrow coming from the hydride. Now you always draw the curly arrows here either from the negative charge or from a lone pair that you might draw next to your hydride. So I'm coming from the negative charge and going onto the carbon. This is going to allow a new bond to form, which means the double bond O has got to break. So I'll have another curly arrow from the double bond onto the oxygen. So this is going to allow this bond to break and a new covalent bond to form between the carbon and the hydrogen. After all, if you look at the compound, we're trying to form this, we're trying to form the primary alcohol. So this extra hydrogen is going to be one of these ones here. So what I'll have then is an intermediate stage in this reaction, in this mechanism. Put the benzene ring back in. The OH that's already there. I'm now going to have something that looks like this. So let's have this one here as the bond, as the double bond, what was originally double bond O. So this now is going to be an O minus. And I've got the two new bonds, that a new bond then forming between the carbon, and one of these hydrogens then would have been this hydride ion here. Okay. So I now need to reproduce the OH group, or make the OH group. So the next bit of the mechanism involves a hydrogen ion. Okay, now what happens here is the hydrogen ion is able to accept electrons from the negatively charged oxygen. Okay, so I'm going to put a lone pair on this one and then a curly arrow, either so from the negative charge or from the lone pair onto that hydrogen to allow a new bond to form. Okay, and then I'll finalise then the final component of this is to draw the final product, which you've already got in compound C. So there wouldn't be a mark for drawing the final product out, but it just ties up the mechanism and finishes it all off. And there we go. So there's your nucleophilic addition mechanism. What you could also do here is you could bring in a water molecule. So the electrons move to the hydrogen of a water molecule, which then a bond will break between the H and the OH. But to do that, you have to show your dipoles on your water as well. But either way, it's perfectly acceptable.